Hello everyone, today I wanted to share a very interesting problem with you. There's a small ball which is jumping in a semi-spherical hole, elastically hitting its walls at 2 points located on the same horizontal line. The time interval between impacts when the ball moves from left to right is always equal to t1, and moving from right to left is t2, which is different from t1. The question is, determine the radius of the hole. Before jumping to solutions, I have pre-drawn a nice picture and then showed all the parameters that I will be using to write my equations. As you can see, the radius of the semi-sphere is indicated as r in red color. The angle of one of the trajectories, the smaller one, is alpha, and the bigger one is beta in orange color. As you might know, the angle of incidence and angle of reflection should be equal, so they are indicated as angle phi. The horizontal separation between two impact points is indicated as an x. Given these parameters, we can write the following equations. Equation number 1. From basic kinematics, we know that the t1 should be equal to 2v sine beta divided by g. Equation number 2. t2 equals 2v sine alpha divided by g. Equation number 3. The horizontal distance x equals to the horizontal component of the velocity v cosine alpha times t2. Equation number 4. The same horizontal distance equals the horizontal component of the velocity according to angle beta times the distance t1. We can write two more equations. From the geometric point of view, we can say that x equals to 2r cosine alpha plus phi. Equation number 6. The angle of beta equals alpha plus 2 phi. We have written all the necessary equations that we will be using to solve our problem. Combining equations 1 and 2, we can get the following relation. G t1 divided by 2 sine beta equals G t2 divided by 2 sine alpha. From here, we get sine beta equals to sine alpha times t1 over t2. And this relation will be useful to us in the future. Combining equations 3 and 4, we get the following relation. t1 cosine beta equals t2 cosine alpha. From here, we get cosine beta equals cosine alpha multiplied by t2 over t1. And this relation is also going to be useful for us in the future. Now, since beta equals to alpha plus 2 phi, we can write down some trigonometric identities. Cosine alpha plus phi equals cosine alpha cosine phi minus sine alpha sine phi. Cosine beta, which is equals to cosine alpha plus 2 phi, can be written as cosine alpha cosine 2 phi minus sine alpha sine 2 phi. Sine beta equals sine alpha plus 2 phi, which is sine alpha cosine 2 phi cosine alpha sine 2 phi. These are just trigonometric identities that we will be using in the future. Now we can use these trigonometric identities along with the combination of equations 3 and 4, where cosine beta equals t2 over t1 times cosine alpha, which in turn equals to cosine alpha cosine 2 phi minus sine alpha sine 2 phi. And in combination with equation 1 and 2, we can also get sine beta equals sine alpha times t1 over t2, which in turn equals to sine alpha cosine 2 phi plus cosine alpha sine 2 phi. The latter comes from the trigonometric identities above. Now, playing around with the last two equations, we can get the following relations. Sine alpha sine 2 phi equals cosine alpha multiplied by cosine 2 phi minus t2 over t1. Similarly, we can get sine alpha times t1 over t2 minus cosine 2 phi equals cosine alpha times sine 2 phi. Now what we can do is just we can divide this equation, the left side and the right side, and to simplify our life. The sine alpha goes away and the cosine alpha cancel. If you don't make any mistake, you should be able to get the following relation. Sine squared 2 phi equals cosine 2 phi minus t2 over t1 multiplied t1 over t2 minus cosine 2 phi. If you manipulate this equation a little bit, and considering the fact that sine square 2 phi plus cosine square 2 phi equals to 1, you should be able to get the following results for cosine 2 phi. 2t1 t2 divided by t1 square plus t2 square. And similarly for sine 2 phi equals t1 square minus t2 square divided t1 square plus t2 squared. These two equations are also going to be useful for us. Now using the fact that cosine 2 phi equals cosine square phi minus sine square phi, or 2 cosine square phi minus 1, or 1 minus 2 sine square phi, we can calculate sine phi and cosine phi. And if you carefully substitute and calculate, you should be able to get the following results. Cosine phi equals t1 plus t2 divided by 2 t1 squared plus t2 squared under the square root. And similarly for sine phi equals to t1 minus t2 divided by 2 t1 squared plus t2 squared under the square root. These relations are also going to be useful for us. Let's keep them. Now using one of the relations that we found in our intermediate step, where sine alpha times sine 2 phi equals cosine alpha times cosine 2 phi minus t2 over t1, we should be able to calculate for sine alpha and cosine alpha using the fact that sine square alpha plus cosine square alpha equals to 1. If you carefully do the calculation, you should be able to find that sine alpha equals t2 over t1 squared plus t2 squared under the square root, and the cosine alpha equals t1 over t1 squared plus t2 squared under the square root. And these two relations are also going to be useful to us. Now we combine equations 2, 4, and 5 and get the following relation. 2r cosine alpha plus phi equals t1 cosine beta times v. And for v, we will substitute g t2 over 2 sine alpha. When we do the substitution, we should be able to get the following. 2r cosine alpha plus phi equals t1 cosine beta multiplied gt2 over 2 sine alpha. gt1 t2 cosine beta over sine alpha. And we know that this is gt1 t2 over 2, where cosine beta is cosine alpha plus 2 phi divided by sine alpha. Now if you expand the equation above, you should be able to get the following relation. 2r cosine alpha cosine phi minus sine alpha sine phi equals to g t1 t2 over 2 cosine alpha cosine 2 phi minus sine alpha sine 2 phi, everything divided by sine alpha. Now if you substitute for cosine alpha, sine alpha, cosine phi, sine phi, cosine 2 phi, and the sine 2 phi, our expressions in terms of t1 and the t2, and after some algebraic manipulation, you should be able to get the following result, where r equals g t1 t2 divided by 2 square root of 2. And this is our final result. If you find this problem interesting, please let me know and subscribe to my channel. Thank you very much for your attention.